My name is Li Xiong. I'm one of the Prepare team members. At this point, especially for those who just joined, we would like to remind you that Prepare is an NSF-sponsored virtual organization intent on building a community of multidisciplinary researchers to take on the next pandemic. Our next mini session is Infodemiology, Social Networks, and Scientific Communication. A special thanks to Angelique, Corthals, and Ajitesh Srivastava for volunteering to serve as co-moderators for this session. They will help guide the discussions after the lightning talks and summarize the discussion. Our first presenter for this session is Yuru Lin.
So hi, good afternoon. My name is Yuru Lin. I'm an associate professor at the University of Pittsburgh. I'm delighted to have this opportunity to present our NSF RP project on countering COVID-19 misinformation. The PI team includes me and my colleagues, Dr. Adriana Koveshka and Dr. Wenting Chong. And we are lucky to have worked with several terrific graduate and undergraduate students. So in this ongoing pandemic, online media is one of the most important means to make people stay tuned with important news and health information. However, as you all aware of, the COVID misinformation spreading across online media and social media in particular has created huge problems. So the goal of this project is to discover new intervention opportunity to counter misinformation. To tackle this problem, we need to better understand the ecosystems that facilitate misinformation spreading. So we try to answer research questions such as what are the misinformation content and who are the misinformation consumers. In this research, we've curated a large longitudinal user samples, user panels, and these include over 500,000 Twitter users in the US, amounting to more than 1.4 billion tweets covering a 6-month period. And we use statistical inference to study users' COVID-related news exposure over time. And we then developed several interpretable predictive deep learning models. And these models are used to identify who are more susceptible to misinformation and what textual or visual content are more likely to spread. So let me highlight 3 important findings from our research. First, when it comes to misinformation proliferation, people thought about bots or super users, but our empirical results show a different picture. Over 90% of problematic shares were from human-like accounts, not bots. And super users were responsible for originating the misinformation, but typical users accounted for around 70% total problematic reshares. And second, we found more than a quarter of typical users whose misinformation consumption changed week by week, meaning their consumption of misinformation was occasional and not steady. And so the misinformation consumption is dynamic in nature. And third, from our interpretable models of textual and visual content, we identify symbolic visual elements such as authorities' faces and nationality symbols. These are more likely to associate powerful but misleading information. So there were a few lessons we would like to share with everyone in this forum. For us, one thing that has gone well is the systematic understanding of misinformation ecosystem. Some of our new findings are counterintuitive and offer practical insights to counter misinformation. If we can have more resources and time, the next step is how we can change users' behavior of consuming and spreading misinformation. And we have not been able to tackle this. So the remaining challenge is how to better consider online populations' different cognitive capability, background, and interests. And we are currently leveraging NLP techniques to create intelligent tools to help users to spot problematic narratives in misinformation and to support users' information literacy. And we are looking for research partners who has expertise in field experimental design or experience in working with communities, especially communities more vulnerable to misinformation. And due to the multidisciplinary nature of this research, we would particularly appreciate supplementary fundings or increasing funding opportunities that encourage cross-institutional or academia community collaborations. And with that, I want to thank you for your listening and happy to take questions.
Hello, everybody. Thank you for inviting me. And my talk is actually very different. I wanted to put it in this session because, as you can read by the project, it was not at all a project about information or any kind of public engagement. It was sort of your basic biology project. But I'm getting to why I have it in this session. So with the team that you saw in the first slide, we developed a project on SARS-CoV-2 viral tropism, noting that a lot of the tropism had to do with mucus-filled epithelia and tissues. And therefore, we thought, we're going to look a little bit closer at goblet cells. Could the goblet cells be more prone to infection by SARS-CoV-2? Now, the strength of Dr. Davalos and Dr. Yo is with bats. And of course, coronaviruses are known to be harbored in bats. And so we looked at how bats differ in their mucous tissues and how there are possibly more goblet cells in our tissues than in bats, particularly those bats that seem to be infected with SARS-CoV-2 but are not affected by it. So that's the project very, very quickly. Thanks to Dr. Yo, who was at Yale at the time and is now at UNC Charlotte, we produced these images, which were first dye-CT scanned of bats and histological slides of bats of the same specimen, even though some of the specimens were over 100 years old, which shows that actually museums are good places to start looking at potential origin of pandemics, or actually looking at pandemics because they contain a lot of tissues that can be important. So the high resolution segmenting that you're seeing here resulted in beautiful images that were allowing us to literally count goblet cells in bats. And why am I in this session? Well, these beautiful images and the fact that we were working with bats attracted NOVA PBS. And we got to do a documentary in the middle of the pandemic. So the filming happened in October 2020 about our work on bats. And you can see here, that's actually one of the iconic images that they absolutely did not use, where they have us look down in a bath of iodine, which reflects, all our faces. So that was actually cute, but 3 days of filming resulted in 2 minutes on screen as usual. And why am I actually talking about this in this session? Well, I just want to relate a little bit our experience with this documentary and how important it is, because this is the face of what's going to appear to the public. And let's not forget that documentaries have a huge responsibility, especially with SARS-CoV-2, where we've seen scientists working on SARS-CoV-2 harassed throughout the world, by the way, for their work on SARS-CoV-2. And so we were lucky that this was PBS NOVA, and they're very serious, and they did their research to the nth degree. And they kept asking us afterwards, whether the results matched what they were going to say in the documentary, even though when we were filming, we had a push from the director to make us say things that we had not yet experimented in and we had no result for yet. So we had to push back against sensationalism and making things sexy when we had no results about the actual thing. This is why I wanted to be here. This was a great experience, but we were very lucky to have a very professional documentarian team. This is not the first documentary that I've done, and by far, this has been the best experience of my life. By and large, they've really stuck to the message we were trying to give. And this has not been my experience for many other documentaries, which actually favor sexiness over the actual fact of the research and basically transforms what a scientist has actually said, just literally by virtue of editing the documentary. So it's important to include this because as scientists, we're not trained as actors and we're not trained into reacting to the press. And this could be problematic. It's a huge problem because when you're not trained to react to the press, you have trained journalists who will sometimes not be as ethical as they should be and will do their own interpretation of your work, which could create fodder, for example, for misinformation, right? One important thing also on the good side is that our work became instantly known. Some people have contacted us because they have seen the documentary. And that was not thanks to our publications, which we have, but it was actually thanks to Nova. So there's the balance, right? So we have instant knowledge of our work through this incredible public media. And at the same time, you have to be careful what you're saying. And we're not trained to be in front of the press. So my message here is for the NSF, could you organize a yearly or bi-yearly conference that actually puts together press professionals and scientists together so that we can be more prepared and the press professional, the media professionals be more prepared about, what the expectations are when you are publicizing scientific data.
Good morning, everyone. So this project that was funded by the NSF had two components to it. One was on misinformation detection, and the other one was on anomalous data detection. So in the interest of time, I'll just present the part on misinformation detection, which is of much interest to most users these days. So this work was done primarily by my student Fatima Hashemi and Hossein Shirazi and Hajar Homayuni, as well as my co-PI, Dr. Shudipta Ghosh. So the importance of misinformation detection in today's age cannot be overemphasized. And it's really causing havoc to our society. And it's impacting the vulnerable populations by looking at misinformation. They are not getting vaccinated and the virus is spreading and there are so many deaths. So I really cannot overemphasize the importance of detecting misinformation in a timely manner. So the goal of this project was to detect misinformation before it has been propagated. So we wanted to do a real-time misinformation detection. So for detecting misinformation, we were going along the use of the language transformers to detect misinformation in tweeted data. So we collected a huge database of tweets, and we used our own retrained transformer model for this purpose. So the first step is we were not interested in analyzing all the tweets because some of them are retweets, some of them contain subjective opinions and emotional content. So we were looking at tweets that contains something that appears to be check-worthy, which the general public will be interested in knowing. So the first step was, we filtered out these emotional content from our data set. Then the next component was some of these tweets are pretty long and they just don't contain a single sentence. Actually, they contain some claim together with the opinion or remark by the author. And so we wanted to label the part that has the claim and separate it out from the remark or the comments of the author. The third part was we wanted to find out what was the stance of the author in terms of this particular claim. For example, garlic cures COVID, this is a lie. So in that case, this whole statement cannot be construed as a misinformation. So we filtered those things out and we fed them into the misinformation detection approach. So here we are looking at two different kinds of approaches. One approach A, we are looking at verified sources of misinformation or verified sources of trusted information and doing a comparison with the claim. And the second approach is we look at the claim, and sometimes the claim cites a news article, trusted news article, and we are doing a comparison between the two. The main results that we found was that, and this is a very interesting result, we looked at the claim made in the tweet, and the tweet had a reference to a news article. And here we looked at a reputed news agencies such as New York Times and CNN. And so we had a set of reputed news sources. So the tweet was referring to a reputed news source. And when we did the comparison of the tweet with the news sources, 1%, there was no similarity. So what this means is that when we look at a tweet and it's referring to some news article, we have a tendency of trusting this tweet, right? Because it's citing some relevant source. But it turned out the news source had nothing to do with the tweet, the claim that was made. And about 1% of tweets were such. And that we say is a source of misinformation. And the other part of the project that we were looking at, we are comparing with trusted misinformation or trusted information. So that is still part of our ongoing work. What has gone well? The data collection, annotations, claim extraction, stance detection, we were able to do it. It wasn't challenging, but it was very labor intensive, but it's kind of doable. We were not able to find trusted sources of information as well as proven sources of misinformation. So that data was missing. So as a result of which we were having to annotate a large selection of data. And the other important challenges that we faced was that sarcasm detection. Currently the natural language processing techniques are not being, we can't detecting, like you have this garlic cures COVID, and then comma, really. So in that case, we were not able to detect the stance or even a contradiction when it's said in a very indirect manner. So those are some of the challenges of the current NLP techniques and which we are looking into right now. And our next work also is planning to look at sources of misinformation, like if some misinformation is coming from a source that a user trusts, we are likely to believe it. And sometimes there is information distortion happening, so which is not attributable to a particular source. So we are looking along these directions. So one of the challenges that we face is about the sharing of the data and the results, actually. That NSF needs to facilitate those, like, how we can freely share, data that we are collecting via tweet and social media with others. So that would be extremely helpful. And also more focus on interdisciplinary research, because clearly, this is a problem that involves the medical community, the social and behavioral scientists, because if we are trying to come up with some solution, then we need those. Can we exploit the biases of the humans in order to stop the spread of misinformation and things like that? So those are some of the ongoing work that we would like to do. Thank you so much.
Hi, I'm Pavel Atanasov, and this is joint work with Regina and Joseph, fellow co-PI and research partner at Pytho, and Soleh Siddiqui at American University. The project was sponsored by a RAPID grant. It was funded in 2020 to study how human forests and random forest models predict the outcomes of COVID-19 vaccine and clinical trials. So the project was set up as a forecasting tournament, and I'll describe what this means in a little bit more detail on the next slide. But it was a tournament between a human forest model, basically a crowdsourcing method, and a random forest machine model. And we were looking to answer two basic research questions. One is, which of those methods are better at producing accurate probabilistic forecasts about clinical trial transition? And the other one is specific to the human forest method, which is how do we help humans generate more accurate predictions? And before we go into the details, we posed several questions of the type, will the Moderna COVID-19 vaccine transition from its current phase 3 to biologic license application by December 31st, 2020, or by February 20th, 2021. So the questions had a time component and a probabilistic component. And at the end of that time period, we could verify the accuracy of those forecasts made by humans or models. So in forecasting tournaments more generally, there are different research teams that submit quantitative forecasts on a mutually agreed forecasting questions on a predefined schedule. So in our case, we're submitting forecasts every week in real time. And at the end of this period, as you can see on the top graph, the human team were submitting forecasts crowdsourced from different individuals. So one individual might say that the event has 35% chance of occurring, and another might say 60, and we aggregate those estimates and submit them. And the model team uses a historical data-driven random forest model and also submits forecasts. And at the end, we can look at those forecasts once the timeline has progressed to see how accurate those forecasts were. Forecasting tournaments offer to promise to accelerate our learning about which methods work in different environments. In this case, the tournaments included both a human and a machine model, but there are various tournaments that only include machine models or only humans. In our case, for the rapid grant, we compared the team level accuracy on 28 time-specific forecasting questions on COVID-19 vaccines and treatments, and we collected almost 2,000 individual human forecasts. The bottom graph shows the result. The dotted line is the performance of the machine learning model, and here the outcome is mean aggregate prior score. So it's a quadratic error measure, so the lower, the better. 0 score means that you're perfectly accurate. 0.5 means you're about a chance. So the machine model performed definitely better than chance, but all of the human methods, we had several different variations, improved on the accuracy of the random forest model by margins of between 32 to 48%. And the human crowdsourced predictions outperformed the model forecast on over 70% of the questions. What has gone well? First of all, it was a somewhat complicated collaboration between a human crowdsourcing team, including myself and Regina Joseph, and the machine modeling team, which was led by Sally Siddiqui. That overall collaboration and research activities were carried out well. On the NSF side, our grant was reviewed very quickly. Obtaining the funds, however, was somewhat delayed, in part due to the pandemic pressures. What are the remaining challenges? We're replicating our study in a second tournament, and it's always a challenge to balance whether you ask more rigorous questions that have a determinate resolution after some time versus how relevant they are. So in this case, we're mostly asking questions about phase transition from phase 1 to phase 2 to phase 3 to biologics license application. But at the time we posed the questions, we didn't have much experience. The FDA didn't have much experience with emergency use authorizations. And many of the vaccines actually were approved through that route. And so our questions were relevant to the general enterprise, but were not specific to that specific regulatory route. We're always looking for collaborations on problems where crowd prediction and machine models can help. And we have worked with NSF very well as a small R&D focused enterprise, and would love to see it have more specific programs towards small for-profit research and development companies. I would like to say that Regina Joseph has another talk based on this project tomorrow at the 3 p.m. session, and we also have a poster for the poster session if you'd like more information. Thank you.
Good afternoon. Big thanks to the organizers for putting this together. It's a big event, and I appreciate that and being invited. My name is Jim Powell, and I'm an assistant research professor at the University of Alaska Southeast and a longtime resident of Juneau, Alaska, the site of our research. I was also on the city council for 9 years and deputy mayor of Juneau, so I have a policy background as well as an environmental background. Our research team has 5 professors and 1 graduate student, and includes Well, considering the broad and complex interdisciplinary nature of our research, this really diverse team was critical. We had 3 universities represented: University of Alaska Southeast, which is in Juneau, University of Alaska Fairbanks, and George Washington University in Washington, D.C. Our project used a case study approach to determine how local government of an isolated coastal community in Southeast is responding to COVID. That's kind of the project overview, or the problem statement. How is the community responding, the whole community, which was really a broad look at COVID-19. We focused on adaptive governance, communications, Alaska tribal response, the economy, and healthcare. And the way we went about it was largely a qualitative approach. For this presentation, I'm going to focus mainly on the communications, which was critical from the start and very much part of this discussion today. So what did we do? We interviewed 61 key informants, and those folks were from local government, indigenous leaders, healthcare folks at the hospital, and business leaders to really look at this broad approach. We now have a draft manuscript on leadership and communications, because that's really boiled to the top as far as some of our findings. And also we did 2 presentations to the university itself, and also 2 public presentations on our preliminary findings. We're also creating a video because we believe that was important for the public to get out. Not just our articles. And it's going to be on the indigenous response, and also of what the city manager did, which was key. So some of the results, I thought this quote from the city manager was really important early on, who was a fantastic leader, very bright guy. He said at the beginning, it's a communications crisis, not just a health crisis. And earlier we heard about that in some of the stuff you guys brought up, and it's so true. So what about this communications? Well, what was important is they acted early, and they did that by increasing the local staff from a half-time public information officer to 8 full-time people. That is an incredible statement of emphasis and public policy. They pulled those people from their libraries that were shut down and other areas, and people that were used to dealing directly with the public. The mayor and city manager gave daily status reports to the public. So it was upfront. And the way they did that was online and also by the radio. So that was a real intention of communications and making sure that the public was getting the information right. And I think that was important. And thirdly, as far as communications, it was a dashboard. And you can see the dashboard up here that I put, and that was taken off just yesterday. And you can see from the responses that, and I think you can probably read them, over 80% of the eligible population has been vaccinated. So that's a statement of effectiveness, I think, on communications. The one up there above it, the online daily update, is what you would see, and that's the city manager that's speaking there. So the effectiveness, I think, proves out that they're doing pretty well, and that was our finding. Institutional structure was really important because the city actually, early on in the city's history, which was unified in 1971. These are newer cities because we're in Alaska. But since 1971, they decided that owning structures was important. They own their own hospitals, local government, they own their own airport. So that really went to reducing the organizational behaviors to collaboration. So institutional structure, communication and leadership, and acting early on. The lessons learned, key informants were very willing to participate. That was good. You don't capture all the information online. That would be a neat thing for a research project for NSF, is to look at the difference between online and in person. What isn't captured, okay? Remaining challenges, reporting on it remains a challenge to all of us researchers, of getting it out. I think that's the biggest thing, getting it out. Needs of collaboration. Videographers, somebody else mentioned videographers. I think that's so important to get the video out. And then suggestions that I put up here as far as the difference between online videos compared to in-person interviews, because that's what we do now because we can't meet otherwise. And one last lesson was that we don't look at problems locally or nationally or internationally holistically enough. And that's what the city manager said. The effects of closing schools had an effect on businesses and bars and everything else. You have to look at the cascading effects. Thank you.